Problem 11.5. Compute the volume of the solids generated when the following sets revolve around the x-axis. Okay, the first one is the curve 1 plus the sine of x. Okay, so this is at 1. The sine starts like this. Well, if I learn to plot. And so here, this is 2 pi. Okay, so it's this curve, right, from 0 to 2 pi, if I painted it correctly. So this is supposed to be pi, okay. So if you rotate this around the x-axis, what you get is kind of a base. If you think about it, you get something like this, right, in 3D, right? This is the x-axis. This is 2 pi. So the volume of this is clearly just applying the formula, right? The volume of a surface or a solid of revolution is pi times the integral from a to b of f of x when the solid is defined by a curve f squared dx, right? In this case, f is just 1 plus the sine, so the volume here is pi times the integral between 0 and 2 pi of 1 plus the sine of x squared. Now this is equal to dx. So this is equal to pi times the integral from 0 to 2 pi of what? 1 plus the sine squared plus 2 times the sine of x. But the sine squared is just 1 minus the cosine of 2x divided by 2, right? So this is equal to dx here, sorry. Pi times the integral between 0 to pi of 3 halves plus 2 times sine of x minus the cosine of 2x over 2. Right? And now this integral is 3/2 times x minus 2 times the cosine minus the sine of 2x divided by 4 from 0 to 2 pi. So when let's see, when x is 2 pi, this is 3 pi, and sorry, all of this times pi, right? So this is 3 pi squared. When x is 0, this is 0. Then when the cosine, when x is 2 pi, the cosine is 1, but it's the same value as at 0, so this is 0. And the sine is 0 at both 2 pi and 0. So the value of this integral is 3 pi squared. Okay, part 2. This is the set is x squared plus y squared greater or equal than r squared and smaller or equal than 4r squared. Well, 4r squared is equal to 2r squared, right? So, and we know that x squared plus y squared equals r squared is the circumference centered at 0 with radius r, right? And x squared plus y squared equals 2r squared is the circumference centered at 0 with radius 2r, right? So what we're revolving around the x-axis is this kind of donut. So what you get, what's the volume of this? Well, you don't need to apply any formula because the volume of this is the volume of this sphere, and we know that the volume of the sphere is 4/3 of pi r cubed, so this is 2r cubed minus the volume of this sphere, which is the the thing in the middle that you're taking out. This is 4/3 of pi r cubed. Now this is 8r cubed. So you have 4/3 of pi r cubed times 8 minus 7, so times 7. So 8 minus 1, 7. So this is 28 over 3 times pi r cubed. That's the volume of this hollow sphere. Okay, and finally, the plane figure delimited by the curves y equals the sine of x and y equals x. with x between 0 and pi. Okay, so between 0 and pi the sine does something like this, right? And x does something like this. This would be a line, right? So this is this figure. It looks like a trumpet somehow, right? So you're rotating this around the x-axis. And now here we can compute this volume again. This volume will be the volume generated by x, right? Pi between 0 and pi, x squared, minus the volume generated by the sine, right? Sine squared. Now this is pi times x cubed divided by 3 between pi and 0. And this is, again, this is 1 minus the cosine of 2x divided by 2. So this is x over 2 minus the sine of 2x over 4 between pi and 0. Now this is pi to the 4 power minus 3 minus, and this is pi squared over 2. At 0 this is 0, and then the sine of 2 pi is 0, the sine of 0 is 0, so this thing is 0. Okay, this is the value of the integral.